All right. So I have two more things to say about chapter 8. The first is just kind of an easy proposition. And this is something that's useful for us. And this kind of relates the idea of zeros and singularities. And I'm just going to write this out so that this gets really straightforward here. But let's let f1 be z minus z naught to the k times g1. And f2 is going to be z minus z naught, so the same z naught to the n times g2 of z, where g1 of z naught is not equal to 0 and g2 of z naught is not equal to 0. So in other words, suppose that f has a 0 z naught, and it's a 0 of order k, and suppose f2 has a 0 z naught of order n. Then let's think about what happens to f1 over f2. So let's let h be the function f1 over f2. And let's think about what's going to happen here. So what's going to happen is we're going to have, this is z minus z naught. This is really not anything surprising, but I just wanted to write this down. This is z minus z naught to the k times g1 divided by z minus z naught to the n times g2. And so what happens is that if k is bigger than n, then h has a 0 at z0 of order k minus n. And 2, if k equals n, then z naught is a removable singularity of h. So it's a removable singularity of h. And then finally, if k is less than n, then h has a pole of order n minus k. And that's, again, at that point z naught. So again, nothing too surprising. This works probably the way that you expected it to work, but just something that's nice to write down.